Assalamu alaikum. I am i236060 roll number 23i6060 from Fast Nusis, Islamabad. This is our digital logic design project titled Whack-a-Mole Game. I worked on the mole generation and timing circuit.
And my name is Muhammad Ibrahim, roll number 23i6090. I worked on the hit detection logic and buzzer feedback.
I am Mohammed Ahmed Akbar, roll number 23i6064, and I was responsible for scoring logic and display system.
Our project is a digital implementation of the popular Whack-a-Mole arcade game. Using basic digital logic components, we created a system where LEDs represent moles that appear in a sequence, and the player responds using push buttons to whack them.
This project showcases how sequential logic circuits, counters, and combinational logic can be used to design interactive hardware. It merges the concepts of timing, decision making, and user input handling in hands on digital systems.
Such a design not only serves as an educational tool to understand how logic gates and counters work together, but also models how user feedback systems are built in real-time applications.
The mole generation section of our circuit relies on a 555 timer, which is configured in astable mode to generate continuous clock pulses. These pulses are fed into the clock input of the CD4017 decade counter. Each clock pulse shifts the active output pin of the 4017 IC, which is connected to an LED. This creates a smooth, sequential pop-up effect of moles, one LED lighting up at a time. This design ensures only one mole is active at any given time, making it easier to check for a correct player response.
To register a successful hit, each LED is paired with a corresponding push button. When a player presses a button, it is compared using logic gates to the active LED. If both match, an AND gate outputs a high signal. We have also used NOT gates to prevent multiple inputs or incorrect detections, ensuring only the correct LED switch pair triggers a hit.
Once a correct hit is detected, a pulse is sent to the clock input of the 4026 IC, which increments the score. The 4026 is ideal as it not only counts the BCD but also directly drives a 7-segment display. The two 4026 ICs are cascaded to represent a 2-digit score from 0 to 99. For additional feedback, the hit also activates a buzzer momentarily, providing an audio cue for the player.
As you can see in our previous simulation, the LEDs representing the moles light up one at a time in a continuous loop controlled by the 4017 counter.
When a player presses the switch corresponding to the currently lit LED, the circuit detects this as a successful hit, triggering a buzzer and advancing the score counter.
The score is displayed on two 7-segment displays. Once the leftmost display shows 3 and the right shows 0, indicating that time is 30 seconds. The clock input to the timer is disabled, effectively ending the game.
This project was a valuable hands-on experience in designing sequential circuits. It deepened our understanding of clock generation, counter behavior, and synchronization. While the circuit worked perfectly in Proteus simulation, it didn't function as expected when we built it physically, due to possible timing mismatches and possibly the low amount of current supplied from the Arduino IC. These things are more precisely handled in software than with real hardware components.
We learned how to use 4017 and 4026 ICs effectively and how to design user interactive systems using only basic logic components without using a microcontroller. Debugging the timing and ensuring accurate score detection also taught us about signal integrity and pulse handling.
In future versions, we plan to implement random mole patterns using additional logic gates or multiplexers and introduce a live tracking system to add more challenge to the game.
Thanks
Thank you
for
for
watching.
watching.